save method. Okay, so this overlap save method is nothing but this using this method we can compute the DFT of a sequence of a long data sequences. Usually we are having a practice of doing a small finite number of sequence. We are applying the DFT of the same. So this overlap save method is used to find the DFT of a long data sequences. So first of all, let's tell about these steps involved in this overlap save method. First of all, we need to segment the long data sequence into small length L, into a small length L. Then the new DFT length n will be found by the formula n equal to m plus L minus 1. Let us assume the input sequence given is 1, 2, 3, something like that up to n. Okay, so this is the length given of a long data sequences. So what we are going to do is we are going to segment this into small blocks. Okay, so the length, the small block, sub blocks length is called as n. Okay, and what is m means? It is the length of the impulse response h of n, length of impulse response h of n. Okay, so now the new DFT length equal to n equal to m plus L minus 1. Okay, so based on this n, we are going to the next step. We are going to form as new sequences having length n by the first sequence. What we are going to do is we are going to append m minus 1 zeros at the beginning. That means, so consider this same example. If this is the sub length 3 and the length h of n equal to also 3 means what's the new length? N equal to 3 plus this is m, this is m and this is n. 3 plus 3 minus 1, that is new length equal to 5. Okay, so to make the length 5, what we are going to do? We are going to append 2 zeros before this one to make this length n equal to 5. Okay, so the next step, the fourth step, here what we are going to do is the last m minus 1 zeros at the from the preceding block to make the length n. Okay, so what I am trying to tell is what we are going to do is when we are considering the next sub block. Okay, next here also we are having 3 elements. Okay, when considering the next 3 elements to make the length n equal to 5, we are considering the previous m minus 1 times. Okay, so then we will perform the convolution. The fifth step is we will perform convolution. And the last step, so we are considering the previous m minus 1 term, the overlapping will be there. So what we are going to do is we are discarding the previous m minus 1 terms and then overlap it and save it. So this method is called as overlap save method. Overall, this overlap save method is used to find the DFT of the sequence of a long data sequences. Okay, so let's solve one problem. Given h of n equal to 1, 1, 1 and x of n equal to 3, minus 1, 0, 1, 3, 2, 0, 1, 2 and 1. So this is the given sequence x of n. Okay, so based on the steps, what we are going to do is we are going to divide into sub blocks. Here I am going to segment this into 3 sub blocks. First 3 elements, first block, next 3 elements and next 3 elements. Okay, so what's the length of L here? L equal to 3 because 1 2 3. What's the length of M here? M equal to 3, 1 2 and 3. Okay, so what's the new DFT length? N equal to, based on the formula, N equal to M plus L minus 1. So that is equal to 3 plus 3 minus 1. So new length N equal to 5. So this is the new DFT. Now what we are going to do? We are going to form the new DFT sequences. Okay, so what will be the first sequences? So x1, we are going to form the sequences. What is x1 of n? X1 of n is nothing but, so already I told that we want to append m minus 1 previously to form n equal to 5. So what we are going to do? We are going to append to m minus 1. M is 3. So 2 zeros we are appending, and then the first block 3 minus 1 and 0. Okay, so once again I am repeating, we are appending m minus 1 zeros and then the following the sub blocks to make this to length n equal to 5. Okay, similarly what we can do? We can write the x2 of n. So considering the second sub blocks, what we want to? We want to consider the previous m minus 1 term. Okay, what about the, for this sub blocks? Okay, one second. For this sub blocks, what about the previous m minus 1 term? That is minus 1 0 1 3 2. Okay, so here these two are the previous m minus 1 term and following that sub block. Similarly we can write x3 of n. What is x3 of n? So the previous term, that is previous m minus 1, 3 comma 2, following the new sub block 0 1 and 2. And similarly x4 of n equal to previous m minus 1 term, that is 1 comma 2 and the sub block 1. Okay, now the length is 3. So what we are going to do? We are going to 0 pad it and make the length n equal to 5. So these are all the new sub blocks created from the long data sequences. So then what we are going to do? We are going to perform circular convolution. So to perform circular convolution, we know that the input sequence and the impulse sequence length should be equal. Okay, here the given value h of n having n equal to 3. So what we are going to do is, we are again, h of n given is 1 1 1. So we are appending 2 zeros to make length n equal to 5. Okay, now what we can do is, we are going to apply convolution. So how we can perform the convolution means, we can perform convolution between x1 of n and h of n, and then x2 of n and h of n. Similarly x3 h of n and x4 h of n. So how we can perform the convolution? So first of all, we want to perform the convolution of x1 of n and h of n. So that is y1 of n. So the first matrix convolution we are performing. So the first matrix, so we 0 0 3 minus 1 0. Okay, so then one shift here. So 0 0 0 3 minus 1. Again shifting once, minus 1 0 0 0 3. Again shifting once, this one 3 minus 1 0 0 0. Again shifting once, 0 3 minus 1 0 0. Convoluted with the h of n, that is 1 1 1 0 0. Okay, now perform matrix multiplication and find the value of y1 of n. How will you perform the metric multiplication? The first metric will be the first row and the column. Okay, so how we will be perform? That is nothing but 0 into 1 and plus 0 into 1 minus 1 into 1 plus 3 into 0 plus 0 into 0. The value will be equal to minus 1. Okay, so once again I am explaining the same step. 0 into 1, that is 0 plus 0 into 0, 0 minus 1 into minus 1, that is plus 1, 3 into minus 1, that is minus 2 plus 0. So this will be written as minus 1. Similarly, in the next step, second row into the same column, 0 into 1 plus 0 into 1 plus 0 into 1 minus 1 into 0 plus 3 into 0, that is 0. Okay, then the third row, 3 into 1, that is 3 plus 0, 0, 0, 0. So that is 3. Then minus 1 into 1, minus 1, 3 into 1, 3, 0, 0, 0. So that is 2. Then 0 into 0, 0 into 1, minus 1 into 1, plus 3 into 1, 0 into 0, 0 into 0. That will be equal to 2. So this is the circular convolution. Okay, the circular convolution performed from x1 of n and h of n. Okay, similarly, what we can do, we can perform the circular convolution between x2 of n and h of n, x3 of n and h of n, and x4 of n and h of n. Okay, so now we want to find y2 of n. How will you perform y2 of n? y2 of n is we are considering the second sequence, minus 1, 0, 1, 3, 2. Okay, so minus 1, 0, 1, 3, 2. Again shifting 2, minus 1, 0, 1, 3. 3, 2, minus 1, 0, 1. 1, 3, 2, minus 1, 0. Again shifting 0, 1, 3, 2, minus 1. Multiplying with the same impulse response, 1, 1, 1, 0, 0. Okay, so multiplying this, minus 1 plus 2 plus 3, that is 4. The first value will be 4. Similarly, 0 minus 1 plus 2, 0, 0, that is 1. Then 1, 0 minus 1, that is 0. Then 3 plus 1, 0, 0. So that is 4. Then 2 plus 3 plus 1, 0, 0. That is 6. So this is y2 of n. Similarly, we need to find y3 of n. y3 of n by taking the input x3 of n. 3, 2, 0, 1, 2. So this value will be 3, 2, 0, 1, 2. Shifting this value once. So 2, 3, 2, 0, 1. Again shifting once. 1, 2, 3, 2, 0. Again shifting once. 0, 1, 2, 3, 2. Again shifting once. 2, 0, 1, 2, 3. So the impulse response will be 1, 1, 1, 0, 0. So multiplying this one, we will get the first value, that is 3 into 1 plus 2 plus 1, that is 6. Then second value 2 plus 3 plus 2, that is 7. Second one, 0 plus 2 plus 3 plus 0 plus 0, that is 5. So it's a simple matrix multiplication. 1 into 1, 1 plus 0 plus 2 plus 0, 0, that is 3. So here also we will get 3. Similarly, we need to find y4 of n, considering the fourth input. What's the fourth subblock? 1 2 1 0 0. So 1 2 1 0 0. Shifting ones, 0 1 2 1 0 0 0 1 2 1 1 0 0 1 2. Again shifting ones, 2 1 0 0 1. So the impulse response 1 1 1 0 0. So the output will be the matrix multiplication 1, the second row into this column, that is 3, and then 4, 3 and 1. Okay, so the convolution part we applied is over. Now what we want to do, so we got 4 convolutions, so we having 4 subblocks, so we perform the convolution for each subblocks and we are having 4 convolution. So now what's the next step? Already I told that after performing the convolution we want to discard the previous m minus 1 term. We want to discard the previous m minus 1 term. Okay, so considering the first input, what's the value? We are having n equal to 5. We want to consider the first m minus 1 term. We want to discard the first m minus 1 term. We need to consider the remaining 3. Okay, so what's the remaining 3 value? 3 2 2. So the final output y of n equal to 3 2 2. That considering second input also we need to discard the first 2 values. So the remaining value, that is 0 4 6 0 4 6. Then third sequence, here also we are discarding first 2, 6 and 7 we are discarding, considering the remaining values 5 3 3 5 3 3. The last sequence also discarding the previous m minus 1 term, that is 1 3 we are discarding, so the remaining term 4 3 and 1. So this is the DFT of the sequence of a long data sequence. Okay, so by the way we can find the DFT of a long data sequence using this overlap save method. Okay, so once again I will recall. So what we can do is we can perform segmentation. We want to divide into sub blocks and we want to find the new length n, and then convolution discarding the previous m minus 1 term. So these are all the steps happening in this overlap save method. Okay, so one thing, if we want to this segment, okay, here we segment it into 3 elements. Okay, so depending upon us. So if you want to segment these blocks having length n equal to 4 means also we can segment it into 4. Let's have an example. The same problem we can do. The same problem having h of n equal to 1 1 1 and x of n equal to 3 minus 1 0 1 3 2 0 1 and 2 1. Okay, the same problem here. What we are going to do is we are going to segment this using having L equal to 4. Okay, so that means 1 2 3 4. So I segmented this having 4 elements, 1 2 3 4. Okay, so I segmented L equal to, here L equal to 4. here m equal to 3. Okay, so what will be the new length? N equal to m plus l minus 1. So n equal to 4 plus 3 minus 1. So new length n equal to 6. So now what we want to do? We want to form a new DFT having length n equal to 6. Okay, so what is x1 of n? So first of all we want to x1 of new DFT having length n equal to 6 up considering the previous values. Okay, for the first element we want to consider upon zeros m minus 1 0. So m minus 1 m equal to 3. So we want to consider two zeros. So x1 of n. So 1 2 zeros 3 minus 1 0 1. This is x1 of n. Then what is x2 of n? Considering the previous m minus 1. So the previous m minus 1 term is this one, right? 0 1. Okay, so 0 1 3 2 0 1. This is x2 of n. Then what about x3 of n? So considering the previous m minus 1 term, this is the x3 of n. So x3 of n equal to 0 1 2 1 upon zeros to make length n equal to 6. Similarly, what we want to do? We want to make the impulse sequence also, that is h of n also having length 6. So 1 1 1 we want to append 3 zeros. So this is the new length. The next step what we want to do? We want to perform convolution. Okay, we want to perform convolution between these two and these two. Okay, so how will you perform convolution? The same method we can perform the convolution. So what is y1 of n? y1 of n equal to convolution of x1 of n into h of n using the matrix method. Okay, so what is x1 of n? Having 6 elements. What's the value? 0 0 3 minus 1 0 1. Okay, so 0 0 3 minus 1 0 1. So here we want to perform shifting 6 times. Okay, so first shift 1 0 0 3 minus 1 0. Again one shift. So 0 1 0 0 3 minus 1. Again one shift. Minus 1 0 1 0 0 3. Again one shift 3 minus 1 0 1 0 0. Again one shift 0 3 minus 1 0 1 0 into the impulse sequence 1 1 1 0 0 0. Now perform the similar way we can perform the matrix multiplication and find y1 of n. Okay, so we want to consider the first row and this column. So what is y1 of n? y1 of n equal to 1 1 3 2 2 0. This is y1 of n. Okay, so similarly we can find y2 of n. How will you perform y2 of n? y2 of n equal to x2 of n in convolution of h of n. Okay, so directly I am writing the answer. By performing the matrix we will get y2 of n equal to 1 2 4 6 5 and 3. Similarly y3 of n equal to 0 1 3 4 3 1. Okay, so these are all the convolution of the sub blocks. Okay, now what we want to do? We want to discard the previous m minus 1 terms. Okay, as we talked earlier, we want to discard the previous m minus 1 term. So what will be the final output? Y of n equal to, so discarding these previous values, y of n equal to 3 2 2 0 and the next one. This sequence also we are discarding the first m minus 1, that is 4, 6, 5, 3. Here 3, 4, 3, 1. So this is the DFT of the given long data sequence. Now compare these two. The given long data sequence is having a long value n equal to 8, 10, 10. Okay, so in the first method we subdivided the subblocks having length L equal to 3. In the second method we subdivided L equal to 4. Compare the answers, we got the same answer. Okay, so what having is changing means the length of the, depending upon the subblocks, the length of the input new DFT sequence is changing. Okay, so by using this overlap save method we can perform the DFT for a long data sequence very efficiently.